Welcome to another session of engineering graphics. In this video, let us study the methods of projections. It includes type of drawings, orthographic projection, important reference planes, concept of first angle and third angle projections, notations used in projection of points and lines, plane of rotation method, quadrant structure, and projection of a point in 4 quadrants. The different types of drawings are nature drawing, that is drawing of landscape, scenery, etc. Geographical drawing, used to draw maps, etc. Botanical drawing means drawing of plants, flowers, etc. Zoological drawing, used for creatures, animals drawing, etc. Portraits, to draw human faces, expressions, etc. And engineering drawing. Mainly, it is classified into two. Building related drawings and machine component drawings. Both may be of the following two types, that is orthographic projection and isometric projection. In orthographic projection, mechanical engineers name the views as front view, top view, side view, etc. Civil engineers name it as plan, elevation, sectional side view, etc. Here the front view is the elevation, top view is the plan, and so on. In isometric projection, the viewer gets a clear idea of the image even if he has not any knowledge in the orthographic projection. So, it is a pictorial drawing or a three-dimensional drawing. See the difference between orthographic projection and isometric drawing. Let us pass on to orthographic projections. It is a technical drawing. Here the object is viewed in three directions and projected to get the front view, top view, and side view. Front view is the view getting on the vertical plane. Top view is the view getting on the horizontal plane. Side view is the view getting a plane called profile plane. Sometimes it is also called picture plane. We are going to see what are these. We can now study the first angle projection and third angle projection methods in detail. As I said earlier, orthographic projection is a technical drawing. The object is projected to different reference planes. Usually when we view any object, we feel that the edges of it converges to a point at infinity. We know that the railway line consists of two parallel tracks. It never meet together. But if we view a track from its center, we feel that it meets at infinity. That is perspective view. But in orthographic projection, the object is projected orthogonally. means the views are projected perpendicular to the respective planes to which we are viewing. The different reference planes are horizontal plane, vertical plane, and profile plane. The profile plane is perpendicular to both HP and VP. HP and VP are mutually perpendicular to planes, and the profile plane is perpendicular to both HP and VP. We get the front view on the vertical plane, top view on the horizontal plane, and side view on the profile plane. Next, we discuss about the different planes, principal planes and auxiliary planes. The principal planes are horizontal plane and vertical plane, that is HP and VP. That's it. The VP and HP. These are two mutually perpendicular planes. Next, we pass on to auxiliary planes. Auxiliary planes may be three types: auxiliary vertical plane, auxiliary inclined plane, and profile plane. Vertical plane and horizontal plane. This is the auxiliary vertical plane. It is perpendicular to HP and it is inclined at an angle with the VP. Next, auxiliary inclined plane. This inclined plane is perpendicular to VP, but it is inclined at an angle with HP. This is the profile plane. You can see that the VP and HP are perpendicular and the profile plane is perpendicular to both HP and VP. There is only two methods for drawing orthographic projections: first angle projection and third angle projection. In first angle projection method, the object to be drawn is placed in the first quadrant and its views are drawn. In third angle projection method, the object is placed in the third quadrant and the views are drawn. The symbolic representation of these two projections are as shown. This is a symbol for first angle projection, and this is the symbol for third angle projection. In first angle projection, the front view is drawn above XY line, top view below the XY line. In third angle projection, front view is below XY line and the top view is above XY line. You can see the difference. This is the XY line, the front view is here, its top view is drawn below XY line, and this is the left side view is drawn at the right side of front view. But in third angle projection, front view is drawn below XY line and top view is drawn above XY line, just opposite to this. Here in first angle projection, the left side view is drawn on the right side. But here in third angle projection, the left side view is drawn on the left side of front view itself. That is a difference. In India, the Bureau of Indian Standards recommended to follow first angle projections only. But in European countries, they follow third angle projection method. Let us see the patterns of planes and its views in first angle projection method. So here is the VP, HP and profile plane. Here is a point. Its front view is seen on the vertical plane. Its top view, or when it is viewed from the top, its view is seen on the horizontal plane. The intersection of these two planes, VP and HP, gives the XY line. The profile plane PP is perpendicular to both HP and VP. The point is at space. And it is not easy to draw the front view, top view, side view, etc. in this case. So, to make it convenient, a method is used. That is, the HP is rotated 90 degree downwards and come parallel to VP. The profile plane also is rotated. That is, we get the side view here. It is rotated towards right and brought to the plane of VP. And we get the front view, top view and left side view on the same plane. HP is rotated downwards. Profile plane is also rotated towards right. And we get front view, top view and left side view on the same plane of vertical plane. Front view, top view and side view. This is the method. Finally, we get all the three views on the same plane, and easily we can understand, or easily we can draw it on a single paper. Let's understand the first angle projection method. The viewing rays are projected towards back. Or we can say the object is in between the observer and the plane. Let us see the illustration of this. This is the object. The observer views it from this side and the rays are projected back. We get the front view here on the vertical plane. Looking from the top, we get the top view on the horizontal plane that comes below here. For side view, it is viewed from this side, left side view, we get on the right side. profile plane, the side view. So here the object is in between the observer and plane. Observer and plane. Observer and plane. This is the method used in first angle projection method. In third angle projection, the plane is in between the observer and object. Let us see this. Observer, plane, object. So the projection rays are projected forward to the plane. In this case, rays are projected towards the plane. Observer, plane and object. The plane is in between the object and observer. We get the top view, vertical plane, observer. Observer is here, plane and object. It is projected forward. We get the front view here. The profile plane. Observer is here, then plane and object. It is projected forward. We get the side view here. That is the method. This is how the orthographic projection of an object is drawn. An example is given. The pictorial view of a machine part is given. Observer views it in first angle projection. The rays are projected back to the plane and we get the front view. Observer looking from the top. Its rays are projected downwards and get the top view on the horizontal plane. The observer viewing from the left side and the rays are projected towards right and we get the side view or left side view at the right side of profile plane. So these three views are drawn on the same plane by rotating the top view and the side view 90 degree. XY line. This is the front view and its top view is drawn below it. The left side view is drawn on the right side of front view. This is the method of drawing orthographic projections of a machine part. Another machine part is given. Let us see how the different views are drawn. Front view, top view and left side view. We know many points are joined together to form a line. Different lines together give different shapes which we call rectangle, triangle, etc. And these rectangles or planes together form a solid. We have to study, or the engineers have to understand the projections of solids, section of solids and its intersection as well. So, first of all, we study the projection of points. Then only we can study the projection of lines and then solids. So, the projection of points is the ABCs of engineering drawing. So let us study the projection of points first. And I repeat, it is the basic for the remaining portion. Before that, we have to understand some notations of a point A and a line AB. So when it is projected, the front view of point A is given the name as A dash. And the front view of a line AB is drawn and given the name as A dash B dash. Similarly, its top view is given the name A and AB for line AB. Its side view is given the name A double dash, and for line AB it is A double dash B double dash. This same system should be followed when using numbers for naming a line or object. Let us understand the quadrant pattern. This is a vertical plane and horizontal plane. So these two planes make 4 quadrants. The intersection of two planes gives a line which we name it as XY line. This is the first quadrant, second quadrant, third quadrant, and fourth quadrant. The front view is always viewed from this direction. Observer looks it from this direction for the front view. And top view is from the top of this quadrants. Looking in this direction, we get these two lines, XY line as a point. Vertical plane, horizontal plane, the observer, first quadrant, second quadrant, third quadrant, and fourth quadrant. So after obtaining the top view, suppose the object is in the first quadrant, we get the front view here and top view on the horizontal plane. This is rotated downwards. Or simply we can say the horizontal plane, this is the horizontal plane, is rotated 90 degree in the clockwise direction, in this direction. So the front part of the horizontal plane comes down and the behind part of horizontal plane goes up. So front part of XY line or front part of front side of vertical plane comes down, of HP comes down, and this portion comes up. This is the method of plane of rotation. It is already explained in slide number 10. You can refer it back. Let us study the projection of a point A. The front view is visible as we get on VP, but top view is getting on the HP. Hence it is rotated 90 degree in the clockwise direction. So if the top view is getting on the front side of XY line, when it rotated, it comes below the XY line. If the behind part of XY line comes above, XY line, this is called plane of rotation. Let us study in detail the processes. The vertical plane, horizontal plane, and its intersection XY is given. XY line is viewed as a point here. Assume a point A in the first quadrant. Always the observer is viewing it from the right hand side for the front view. So we get the front view on the vertical plane and it is named as A dash. The top view comes on the horizontal plane in front of XY line. As HP is rotated 90-degree clockwise, it comes down. So the top view of point A, that is A, notation small letter A, comes on the same plane of vertical plane. And it is drawn like this. On the XY line, A dash at the top and A below XY line. Usually, when we do problems, the location of point A will be given as point A is 20 millimeter in front of VP and 40 millimeter above HP. 40 millimeter above HP. So looking in this direction, we get the point A or A dash at a distance of 40 millimeter above XY line. From this line, we get 40 millimeter above XY line. And looking from the top, we get the point A here, that is 20 millimeter in front of XY line. When it is rotated, the point A comes below XY line at a distance of this distance, that is 20 millimeter below XY line. This is the method of projection. Or it is the method of projection of a point A when it is at the first quadrant. In different quadrants. Projection of a point in first quadrant. Different solutions are given here. This is the point A in space in the first quadrant. Front view and top view. Front view will be getting on vertical plane, point A dash, and top view A on HP. The orthographic presentation is given. A dash above XY line and A below XY line. Another point above HP and on VP. Above HP and on VP. So in front view, point A is the same as point A dash. And looking for the top view, when it is viewed from the top, we get point A on the XY line. See, the orthographic presentation is given here. A dash here and A here. Another point A on HP and in front of VP. Point A is on HP and in front of VP. when viewed from the top, we get the top view at a distance of this below xy line, and the front view, we get the front view on xy line. So point A dash will be here and A here. So A dash on xy line and point A below xy line. Similarly, the points on second, third and fourth quadrants have to be studied. A point is placed in different quadrants by rotation of plane method. Its top view is brought on the same plane of vertical plane. Let us see this. Point A in first quadrant, front view A dash, top view A, and rotated, we get below xy line. Point A below xy line. In second quadrant, observer is always viewing from the right hand side. Point A, its front view will be on the vertical plane. Point A dash, top view is below A and it is rotated upwards. We get A dash, point A above xy line. So here A dash and A will be above xy line. The point in third quadrant, the front view will be below xy line, A dash, and top view will be behind xy line, and when rotated it comes up. Point A. In fourth quadrant, point A is in fourth quadrant. It is viewed from the right hand side. We get point A dash on the vertical plane below xy line, and top view comes on the horizontal plane in front of xy line. When it is rotated, it also comes below xy line. So let us make a comparative study of the point A in first quadrant and third quadrant. This is the method of first angle projection, and this is the method of third angle projection. In first angle projection, the object is placed in the first quadrant. In third angle projection, the object is placed in the third quadrant. When it is viewed in the first quadrant, we get the front view above xy line and top view below xy line. Here, when it is viewed from the front, we get the front view below xy line and top view above xy line. It is just opposite to the projection method used in first angle projection. Here A dash here and A here. In third angle, A dash is here and A is here. That's the difference. Similarly, let us compare the points in second quadrant and fourth quadrant. When the point is in second quadrant, both the front view and top view will be above xy line. While when the point is in the fourth quadrant, the front view and top view will be below xy line. Before we end, the main points once again. During orthographic projection, wherever is the object, the front view top view and side view are brought in the same plane to see it clearly for the observer. In first angle projection method, front view is above xy line, top view is drawn below the front view, and left hand side view is drawn on the right side of front view. Front view, left side view, and top view. When the point is in the first quadrant, front view above xy line, top view below xy line. When the point is in the second quadrant, both front view and top view will be above xy line. When the point is in the third quadrant, opposite to this, front view below xy line and top view above xy line. When the point is in the fourth quadrant, opposite to this, that is both front view and top view will be below xy line. That's all. Thank you.